Okay, working with rational expressions, functions, and equations. We can add them, subtract them, multiply, divide, simplify expressions. Functions, we can identify vertical asymptotes and points of discontinuity. It's where there's holes in the graph. And with rational equations, we can solve them. So first off, simplifying. There's two basic steps. One, factor everything, cancel common factors. On multiplying, you still factor everything, you cancel common factors, and then you simplify. So a couple examples. We have, for simplify, 2x squared plus 4x divided by x squared minus 4x minus 12. Factor the numerator, factor the denominator. Numerator has common factor of 2x, so 2x times x plus 2. On the bottom, it's a trinomial. X goes up front in each, and then factors of 12 that are 4 apart. Well, negative 12 means one's positive, one's negative. Two factors of 12 that are far apart are 6 and 2. 6 has to be negative, and the 2 positive. Now we look at the common factors, top and bottom. We've got x plus 2, so we can cancel those. That leaves us with just 2x over x minus 6. Multiplying, we have x minus 4 over x cubed plus 1 times x squared minus x plus 1 over x minus 4. Factor, well, the only one that factors is the x cubed plus 1. That's a sum of cubes. And that factors into x plus 1 times x squared minus x plus 1. Cancel common factors. The x minus 4's are the same. The x squared minus x plus 1's the same. And we are left with, when we simplify, 1 on top and x plus 1 on the bottom. Rational expressions, you do have to be careful because every time you cancel common terms, you're killing a kitten. Please save the kittens. So, in dividing, we still can only cancel common factors. So we still factor everything, multiply by the reciprocal, because we're dividing by a fraction, and then cancel common factors and simplify. And on adding or subtracting, this is just like fractions. You find a common denominator, get a common denominator, add or subtract, and then factor the numerator again if you can, and simplify. So 3 over x plus 7 divided by 8x squared minus 8x over x squared plus 6x minus 7. Factor everything. The 3 over x plus 7 can't do anything with it. 8x squared minus 8x, well, we can pull out an 8x, and that leaves with x minus 1. On the bottom, x squared plus 6x minus 7. Factors of negative 7 that add up to 6, well, that would be negative 1 and positive 7. And notice here, I also changed it to multiply and flipped it already, multiply by the reciprocal. Cancel common factors, x minus 1's and x plus 7's. And that leaves us with 3 over 8x. On the adding or subtracting, we have 7 over 3x minus 9 minus x plus 4 over x squared minus 9. Factor the denominators. So that gives us 7 over 3 times x minus 3 minus x plus 4 over x minus 3 times x plus 3. They both have an x minus 3, so that's part of our least common denominator. The first fraction has a 3 in the denominator, and the second has an x plus 3. We need each of those separate factors. So our least common or lowest common denominator is 3 times x minus 3 times x plus 3. Multiply each fraction by what it needs top and bottom to make it a common denominator. The first one is missing x plus 3, so I multiply top and bottom by x plus 3. The second is missing just 3. So on the first fraction, multiply top and bottom by x plus 3. On the second fraction, multiply top and bottom by 3. So the top of the first fraction will give us 7x plus 21. The second, that's subtraction, so I could just multiply through by a negative 3, gives us negative 3x minus 12 over the common denominator. Here, I haven't shown multiplying it out yet. Here I simplified without showing it multiplied out. If you look at it, we got 7x minus 3x is 4x. 21 minus a 12 is 9. Check, can we factor that 4x plus 9? No, the only thing that goes into it's 1. So that's it. Okay. Functions. We can graph them, and working through graphing with vertical and horizontal asymptotes and finding domain and range. That's another recording that I've got. And that's to graph them. That'll be coming up. But might as well talk about how you find vertical asymptotes. If function is in simplest terms, then wherever the function is undefined for x equals a, then x equals a is a vertical asymptote. A point of discontinuity is if the original function is undefined at x equals a, but the rational expression in simplest form is defined for x equals a, then there's a point of discontinuity at x equals a. What does that look like for finding vertical asymptotes and points of discontinuity is on the next examples. We want to find vertical asymptotes and any points of discontinuity for both of these examples. First thing you do is you factor the numerator and denominator. The one on the left, 8x squared minus 8x, is just 8x times x minus 1, and the bottom factors into x minus 1 and x plus 7. On the second one, x plus 4 doesn't factor, and x squared minus 9 factors into x minus 3, x plus 3. Okay. Cancel common factors. So on the first one, x minus 1 is the same top and bottom, so we can simplify it. On the second one, the one on the example on the right, there aren't any common factors top and bottom, so we just write it again. Third step is whatever makes the denominator 0 is in the reduced function is a vertical asymptote. So on the left example, we have x plus 7. We set that equal to 0. What plus 7 is 0? Well, negative 7. So it has a vertical asymptote of negative 7. That's x equals negative 7. On the other one, we take 0 equals x minus 3. 0 equals x plus 3. What makes both of those 0 is a positive 3 and a negative 3. So the vertical asymptotes are 3 and negative 3. For the factor that canceled, find what makes it 0. Plug that value into the reduced function to find the point of discontinuity. Only the one on the left had a factor that canceled, and that was x minus 1. What makes it 0 is 1. And so we plug that into the function for x, the reduced function. So 8 times 1 is 8. 1 plus 7 is 8 on the bottom. 8 divided by 8 is 1. So the point of discontinuity is at 1, 1. The example on the right has no point of discontinuity. Okay. Now, last one. Solving. To solve, we identify any excluded values. Those are numbers that make the denominator 0. We multiply by the least common denominator to every numerator. We simplify, cancel all common factors, then we solve and check our answer. So I got a couple examples here. Here we have 5 over 24 plus 2 over 3 minus x equals 1 over 4. The excluded value would be x can't be 3. That's the one value that makes the denominator 0. And our common denominator, well, factor it 4 times 6, 3 minus x and 4. So our common denominator, we need a 4, a 6, and a 3 minus x. Multiply everything by 4 times 6 times 3 minus x, and then cancel any common factors. On the first fraction, 4 times 6 cancels. On the second one, 3 minus x cancels. On the last one, just the 4's cancel. Then we simplify. 5 times 3 minus x, well, that's going to be 15 minus 5x. 2 times 4 times 6, well, 4 times 6 is 24, times 2 is 48. And on the right, 1 times 6 is 6, times 3 minus x, well, that's going to be 18 minus 6x. Then solve. Get the x's on the same side, so I'm going to add 6x to both sides, 15 and 48. 48 and 10 is 58, plus 5 more is 63. Subtract 63 from both sides. 18 minus 63 is negative 45. Negative 5x plus 6x is 1x. And so our solution is x equals negative 45. Second example, a little bit more involved, but the same steps. Our excluded values are negative 1 and 1 because p squared minus 1 factors into p plus 1 times p minus 1. Factor the only one that needs to be factored. find our common denominator? Well, we need 1, p minus 1, and p plus 1. Multiply everybody by the common denominator. Cancel common factors. The p plus 1's in the first fraction cancel. P minus 1 and p plus 1 cancel in the second fraction. And just 1 cancels in the last. Simplify p squared minus p plus 1 times p minus 1. Multiply that out. P squared minus 7 times 1 is just p squared minus 7. And then p times p minus 1 times p plus 1. Well, p minus 1 times p plus 1 is p squared minus 1 times p gives us p cubed minus p. And then we can start combining like terms. Well, the p to the thirds cancel. We've got negative 2p squared, move that to the right, so it gives us 3p squared on the right. Subtract 2p gives us minus 3p on the right, and then move the 1 over. Negative 7 plus 1 is 6. Factor, because it's quadratic, can pull out a 3, and then p squared minus p minus 2 factors into p plus 1 times p minus 2. What makes each of those 0 is negative 1 and 2. Here's when we look back at our excluded values. Negative 1 gets excluded because it makes the original one of the original denominators 0, means it's an extraneous solution. So our answer, the solution is p equals 2. P equals negative 1 is an extraneous solution. This should help with some of our solving and also working with simplifying some of our rational expressions.